Hello, in this short video I'm going to solve the following A-level problem. Show that y equals to sine of sine x is a solution to the following differential equation y double prime plus tan x times y prime plus y times cosine x squared equals 0. Pause the video at this point and give it a try. Okay, so now let us solve this problem. A function is proposed. We are supposed to investigate that this function is a solution to this differential equation. It's a simple problem. It's mainly a practice in differentiation, okay? Okay, but you understand that this x is the argument of sine, and then sine of x is a number. That number, expressed in radians, of course, will be the argument of the second sine. So this is sine of the sine of x. And we want to show that this will fit in this differential equation. So what does it mean? It means that I have to calculate y prime, I calculate y double prime, and then instead of y prime, and y double prime, I put expressions in terms of x, and hopefully if we do everything correctly, we will see that everything will be simplified to 0 regardless of which value of x we are looking at, independent of the value of x. The first thing that I want to do is to take the derivative. Okay, but this one in your head, you can consider it as u. So sine of u, according to the chain rule, the derivative of sine u becomes cosine of u, but you have to multiply it by the derivative of u, which in this case is sine x. But the derivative of sine x is simply cosine. So this becomes, if you don't mind, let me write cosine on the left. So it becomes cosine x multiplied by cosine of sine x. This is the first derivative. But now the first derivative is a product of two functions. So if I want to calculate the second derivative, it means that I have to calculate the derivative of this product, which is equal to the derivative of the first one times the second one itself, plus the first one times the derivative of the second. Okay, so I would say that the derivative of the first one is minus sine x multiplied by the second function itself, and then plus the first function itself multiplied by the derivative of cosine of a function. Again, in your head, you can imagine this is u, cosine of u. The derivative becomes minus sine of u, but u is sine x, multiplied by the derivative of u, which is the derivative of sine x, which becomes cosine x. Let me write this a little bit more organized. So y double prime becomes equal. I mean, this is good enough, so let me just copy and paste. But this one, I have a minus sign here. I have a cosine here and cosine there, so it becomes minus cosine x squared. And then I have sine of x, yes? This is my second derivative. Now I put everything back into my differential equation. So the left-hand side becomes simply this expression that I just calculated. This is y double prime. Then this is my y prime. I have to multiply it by tangent. The tangent, you know, is sine over cosine. So I have to multiply tangent by the first derivative. This cosine in the denominator will cancel this cosine. Sine x is left, multiplied by cosine of sine x. So it becomes sine x multiplied by cosine of sine x. Yes, so this is tangent x times y prime. But then I have y times cosine x squared. So if you don't mind, let me write cosine x squared first, and then multiply it by y, which is sine of x. And if I have done everything right, everything should cancel out, and actually it does, yes, because this minus sine x cosine sine x will cancel this one. sine x cosine sine x. Let me double check. Minus sine x cosine sine x. Yes, that's correct. So this one will cancel that one. And this one and that one are identical with opposite signs, but they also cancel out. And the answer is 0, which is equal to the right-hand side. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.